Okay, we're now going to look at scatter graphs, and we're going to look at drawing them, and we're going to look at reading them. So, a scatter graph is used to compare two sets of data. So here we've got, for different types of birds, we've got the length measurements, and we've got the wingspan measurements. So we're going to draw a scatter graph to compare the length of the birds to the wingspan of the birds. So the first thing to do is to draw a set of axes. In an exam, this is often done for you. So here we've got a set of axes. We've got length of the bird along the x-axis, and we have got the wingspan of the bird along the vertical axis, the y-axis. The first thing then to do is to plot the points onto the graph. So the first point has got a length of 21 and a wingspan of 40. So we're going to go 21 on the length, and we're going to go up to 40. So 21 across, up 40 would be there. And then we do the next point. The next point was 25 across, 36 up. So we're going to go 25 across and 36 up. And we're going to continue that for the whole table. So we've done the first 2 points, we'll then do that for all of the points. Okay, I've now plotted the 7 points, and they look something like this on the scatter graph. As you can see, it's going up with a positive correlation. Watch the video on scatter graph correlation now to see what I'm talking about. Okay, so positive correlation is as the wingspan gets bigger, or as the length gets bigger, so does the wingspan. So it's going up from bottom left to top right. So it's going up in a positive correlation. So we're going to answer some questions now on this. The first one is to draw a line of best fit on your scatter graph. So to do that, you're going to need to get yourself your ruler. I'd recommend getting yourself your 30cm ruler, so a large ruler like that, and a pencil. So, whenever you're drawing a scatter line of best fit, the thing to consider is that you want to try and get as many of you want to get the points as close to the line as possible. You want to make sure that there's an even number above the line and below the line, and that the line's going through the points as closely as possible. So, if I was to do it for this set of data, I might do something that looks like this. So there's my line of best fit. You'll notice, it's going to carry it on. You'll notice that I went not only through the data, or through the points, but I carried on all the way until the y-axis. I didn't go any further, and I carried on that way as well. And you'll see that it goes through exactly 1, 2 points, and then you've got 1, 2 above and 2 below. Don't worry too much about sort of making your line of best fit perfect. You'll not see how to do that until you do A-level maths. You know, in the exam they've got sort of tolerance, so you can have it sort of as close to you. They'll have a template that they'll put over the diagram and see and make sure your line of best fit's in a suitable region. Okay, so don't worry too much about drawing it. Just making sure that it's going through as close to the points as possible. It doesn't have to. Some students make the mistake of thinking it has to go through the origin, the point 0, 0. It doesn't. Okay, you'll see clearly from my line of best fit, it crosses here at about 3.5. Okay, now we're going to answer our next question. The next question says, describe the strength and the type of correlation. So, watching the video on scatter graph correlation, you'll see that this has got a positive correlation. Now, the strength of the correlation. If the points are really close to the line of best fit, then it's called a strong positive or strong negative correlation. If the points are loosely connected, or loosely, or if they're surrounding the line, so if they're really close to the line of best fit, it's called a strong correlation. If they're spread out quite a lot but still going up in the positive direction, then it's called a weak positive. This would definitely be a strong positive correlation, because you can see that the points are very close to the line of best fit. Okay, next question. The next question says, use your line of best fit to estimate the wingspan of a thrush whose length is 20 centimeters. So we're going to use this orange line of best fit to make an estimation. That's only an estimation because remember everyone's line of best fit might be slightly different. So we're going to use a line of best fit to make an estimation of the wingspan for a thrush that is 20 centimeters long. So get yourself your pencil and get yourself your ruler, and it said that its length is 20 centimeters. So you'll see here length 20 centimeters, and we want to find the wingspan. So we get our ruler and we go from the 20 centimeters up to the line of best fit. Always do this on your diagram, okay? Quite often students will just read it off with their finger and they'll go across a bit. Use your ruler like I have, okay? So we've gone up from 20 to the line of best fit and we're going to go across. And whenever I've gone across, now this isn't precise because my marker's quite thick, but you'll see here that I've got to 33 centimeters, okay? So my answer would be, whenever I have my question, it says use your line of best fit to make an estimation of the wingspan of a thrush whose length is 20 centimeters. The wingspan would be 33 centimeters. If it asked you to work out the length using the wingspan, just say for instance it says estimate the length of a bird with a wingspan of 40 centimeters, you'd get your ruler, you'd go across from 40 and down. The last question is, it is not sensible to use your line of best fit to estimate the wingspan of a pigeon whose length is 41 centimeters. Explain why. Okay, now I'm actually going to use the original data here. So here's the original data, and the length of the pigeon is 41 centimeters. Well, as you can see here, the longest bird that we had was 32 centimeters, and that point here is the dove that's all the way over here. Okay, now the pigeon, they say, has a length of 41 centimeters, so it would be over here somewhere, right? As you can see, it's beyond the range of the data, okay? It's beyond the points that we've given, okay? So it's quite, whenever you're using your line of best fit, anything between this point here and this point up here would give you a reasonable estimation. However, if you were to go for a point up here, or if you wanted to make an estimation for length down here, it's beyond the range of the data, so you don't know for certain what's going to happen. If you study physics, there's a thing called Hooke's law, and you'll see exactly what I mean. So the answer here would be, explain why. I would just write the pigeon would be beyond the range of data.